Hi, Violet. So let's talk about this. No, that's not yours. Let's talk about this. Okay. So well, this is not the question about Mars lander. This question is about the space station. So what we have here is we have a person that if they were out in space, this is a little space helmet, all right, and they're out in space, their force of gravity is equal to mass times gravity. And since gravity is equal to 0 in space, then the force of gravity would be equal to their mass times 0. And so their weight in space, their force of gravity, which is also known as weight, will be 0 newtons in space because they're out floating. But if we put them inside of a rotating space station, they can now take their helmet off because they're in the space station. We said, okay, wow, how do we get gravity now? So they get gravity because the space station is going to be spinning with some velocity. And so this fake gravity will actually be Fc, and it will feel like like Fg. It'll feel like gravity. Maybe you get a little bit dizzy, perhaps, if it was not huge. You might feel like you're in a amusement park ride. But that is found by finding the mass and then timesing it by velocity squared and then dividing it by the radius. And the radius, of course, is the radius here. And the mass is this mass here. So this is a two-step problem. You were doing this. This is true. But that's how it is outside. It says, unless the station is rotating in fake gravity, the object would have no weight or gravity pull down. That is true. But we're telling you that this is rotating at 1 RPM, which means 1 revolution every 60 seconds. So how far is a revolution? Well, a revolution is pi times diameter, because that is what's called circumference. A circle, their circumference is going to be pi times diameter. It's also 2 pi r, but 2 pi r and pi times diameter are the same thing. So the way you do this first question is the tangential velocity is going to be v equals the distance traveled over the time, right? Well, what's the difference distance traveled? It's 1 circumference, which is pi times diameter. What's the time? 60 seconds. And so that is going to give you an answer in meters per second. Okay. Then how much it would weigh on this space station. And this space station is spinning. How fast is it spinning? It's spinning 1 RPM. Okay. So then just instead of doing that, that's how much it would weigh in space. That's true. Do this. Fc equals mv squared over r. And that will be your weight. But it won't really be gravitational weight. It will be the weight that you feel because of your inertia being caused to spin in a circle. So yeah, the Fg equals 0, but the Fc is going to be faking you into thinking that you have an Fg. So give that a try, and that's the whole thing. So hopefully that helps. I can't find my place to put the there it is.